Hello, class, and welcome to today's lecture. Our topic for today is solve equations involving one and two variables. Let's start by looking at what a polynomial is. So a polynomial in one variable x is expressed as n x to the power n plus n minus 1 x to the power n minus 1 plus all the way to a1x plus a0, where each of the a's is not equal to 0. And in this case, the an's are the coefficients of the polynomial, and the x's are the variables of the polynomial, and the exponents are the exponents of the variables. In the case of a1x1, x has an exponent of 1, and usually it is not written when it has any variable or number has an exponent of 1. In the case of a0, x is raised to the power 0, and any number raised to the power 0 is 1. So we have a0 times 1. That is why we didn't write the x at all. So let's see something here. This a1 x1 is also a1 x to the power 1. But usually when we have numbers or variables, we don't write this one. So you see it as a1x. Again, with this a0, it's actually a0 x to the power 0. However, any number raised to the power 0 is equal to 1. So this is seen as a0 times 1, okay? And that's also equal to just a0. That is why you see just a0 here. So this is to explain why you see the last two terms the way they are. And please note that the coefficients an's should not be equal to 0, because if it's equal to 0, for example, in this one, a1 times x, if a1 is equal to 0, we have 0 times x, and that means it's equal to 0. So this term will not be there. This term will be equal to 0. But in this expression, as you can see, it is not equal to 0. So a0 should, under any circumstance, be equal to 0 so that each of the terms can be valid. Polynomials are algebraic expressions that meet further criteria. So they are simply algebraic expressions, but they meet a certain criteria. Now, what criteria is this? The criteria is that a polynomial consists of only a number, which is the coefficient, multiplied by variables, and it is raised to a positive exponent. So you have a number, an, multiplied by a variable, x, and the variable is raised to a positive exponent. So these n's that you are seeing, n minus 1, n minus 2, all the way going, it should be greater than 0. Each of the n's should be greater than 0. None of them should be a negative number. So how do we know the degree of a polynomial? We first of all need to know the degree of the polynomial terms. When we say polynomial terms, if you look at this polynomial, these are the terms of the polynomial. So this is one term, this is a term, this is also a term. Now this too is a term and this is a term. So each of the components of the whole expression that is being separated by the mathematical operatives, the addition, they are what we call the term. Therefore, if you want to know the degree of a term of a polynomial, you pick that term, then you add all the exponents within that term. So in this example, we have 2x to the power 4, y to the power 3. The exponents in here are 4 and 3. So we add 4 plus 3 to get 7. And we conclude that 7 is the exponent of this term. What about question number 2? 5x to the power minus 2, y to the power 5. In the first place, this cannot be a term of a polynomial because we indicated in the previous slides that the exponents must be greater than 0. It cannot be negative. Once we see a negative in the exponents, this is disqualified from being a term of a polynomial. So this expression is not a term of a polynomial. So we don't even need to go further to find a degree. What about this term? It's a constant, 8. Now, as I mentioned earlier on, for the constant, there is some variable with the power 0 that is not showing because this variable with the power 0 is 1, and 8 times 1 is still 8. So we conclude that the degree on the variable is 0, so the degree of this polynomial is 0. A constant term has a degree of 0. Finally, 0 has no defined degree because, as mentioned, once we have 0, it means the coefficient is equal to 0. And we noted that for polynomial, each of the terms should not have a coefficient equal to 0. The ANs should not be equal to 0. So this is showing that that AN is equal to 0. If that's the case, then we cannot even find the degree of the term at all because it even fails to meet the criteria of a term of a polynomial. So let's move to these examples. State the degree of the following polynomials. Number one has just one term. Number 2 has two terms. It has minus 11x squared and 3xyz. Number 4 has four terms. It has a to the power 9, 4a to the power 3, 7a squared, 10. So let's start with question 1. For question 1, the polynomial has one term, 7xyz. For each of these, they have a degree of 1 on them that is not showing, y to the power 1, z to the power 1. So if you add 1 plus 1 plus 1, you are getting 3. Therefore, the degree of this polynomial is 3. Let's look at number 2. Minus 11x squared plus 3xyz. We have to find the degree of each of the terms separately. So for number 2, the degree of the first term for number 2, we have here YZ. The degree of the first term is 2. The degree of the second term is 3. Now, how do you determine the degree of the whole polynomial? Okay, you're supposed to find the degree of the entire expression, this whole expression. All right. You find it by determining the biggest number. So 2 and 3, the biggest number is 3. Therefore, we conclude that the degree of the entire polynomial is 3. So the degree of the entire polynomial takes on the degree of the term that has the biggest degree. What about number 3? The degree of the first term is, for number 3, we have 1 plus 3z. The degree of the first term is, remember, for constant, the degree is 0. And the degree of the second term, 3z to the power 1, is 1. 0 and 1, 1 is the biggest. So the degree of the entire polynomial expression is 1. Now we have a to the power 9 plus 4a to the power 3 plus 7a squared plus 10. Of all of these, the degree of the first term is 9. Degree of second term is 3. Degree of third term is 2. Degree of last term is 0. So of these four numbers, the biggest number is 9. So we conclude that the degree of the entire expression is equal to 9. Finally, for question 5, the degree of the first term is 2. Degree of second term, 2. Degree of last term, 1. Of these three numbers, the biggest one is 2. Even though 2 is occurring 2 times, it doesn't matter. You still stick with the biggest number, and then you choose that the degree of the entire expression is 2. So these are the results of finding the degree of the polynomial. So this is a practice example for you. State the degree of the following polynomials. Here are some hints for solving polynomials. To know the degree of a term is simply to sum the exponents of its variables. But to know the degree of a polynomial, you choose the largest degree amongst its terms. For constant terms, they have a degree of 0. So here is more example for you to practice. Identify the degree of each polynomial. Really, good morning. How are you? Okay, I'm recording a lecture. I have to start with them at 8 o'clock, so the kids need to get to school before 8. But I'm still recording. So if you could please prep their things and you can start prepping them. When I'm done recording, I'll come and help, then I take them to school. So when you're done with their bag, you could start bathing them. Thank you. Now let's look at what a linear equation is. What is a linear equation in one variable? A linear equation is an algebraic equation with a degree of 1. This means that the highest exponent on any variable in the equation is 1. The general form is ax plus b equals 0, where a should not be equal to 0, and a and b are real numbers. So look at this example. We have 3x plus 2 equals 0. In this case, a is equal to 3, b is equal to 2. We define a as the coefficient. We define b as the constant. 0 also is a constant. And then x is a variable. So these are the definitions around a linear equation. In this example, 3x plus 2 equals 0. 2 and 0 are constants. 3 is the coefficient of x, and x is the variable. Well, how do you solve a linear equation in one variable? The first step is to simplify anything that is within a bracket. And then you also try to remove brackets, or you use the distributive property to expand the bracket. Then you collect like terms, you isolate the unknown variable, and then you simplify. So let's try some examples. Example, these are 5 examples we can try. Question 1. Solve the main question is saying that solve for x. So in each of these polynomials, or in each of these algebraic expressions, we will solve for x. So question 1, x plus 5 equals minus 2. I'm solving this question. The focus is to make x stand alone, and then we simplify the other side of the equation. So let x stand alone in this case. I'll take 5 from here and then also do the same thing to the right-hand side so that the equation is balanced. So I have here x plus 5 minus 5 equals minus 2 minus 5. Now minus 5 cancels minus 5, and I have x equals minus 2 minus 7, giving me minus 2 minus 5, giving me minus 7. Note you can use a calculator to do these calculations. You just key in minus 2 minus 5 and it gives you your response. So in the case of number 1, we have x is equal to minus 7. Now for number 2, we have 3x equals 24. What do we do? 3 is multiplying x. So the inverse operation of multiplication is division. So I can divide here by 3 to remove the 3 and do the same thing to the right-hand side. The 3 cancels out the 3. I have here x being equal to 24 divided by 3 is 8. So in the case of number 2, x is equal to 8. Let's look at number 3. I have 3x plus 15 equals x plus 25. What do we do? First of all, I know my x must stand alone, but there's x here and there's x here. So I'll move one of the x's to join the other. I'll move this x to join 3x. The x here is a positive x. So when I cross it over the equal sign, it will become a negative x. So I'll have here 3x minus x. Now, I'm going to also move this 15 to join its counterpart, which is 25. 15 here is positive. If I move it, it becomes negative 15. So I have equals 25 minus 15. Now to simplify, 3x minus x gives me 2x. And 25 minus 15 gives me 10. I still want to make x stand alone. Now 2 is multiplying x, so I can divide here by 2 to remove the 2 and do the same thing to the right-hand side. I have 2 cancels out 2. 2 goes here 1, 2 goes here 5. So eventually I have my x being equal to 5. So in this case, x is equal to 5. For question 5, no, that's not right. Let me change it. So number question 4 rather. I'll skip question 4. Okay, let's do it. Question 4, we have 2x plus 1 equals 3, 4 minus x. So this gives me, I'm going to open up the bracket. So 2 will multiply through each of the terms within the bracket. So 2 times x is 2x plus 2 times 1, positive 1 is positive 2. Okay. Now 3 also multiplies everything that is in the bracket here. So 3 times positive 4 is 12. Then 3 times minus x is minus 3x. I have 2x plus 2 equals 12 minus 3x. I'm going to move this minus 3x across the equal sign to join its counterparts, which is 2x. And I'll move these 2 to also join 12, which is its counterpart. Now minus 3x crosses the equal sign to become minus 3x crosses the equal sign to become positive 3x. So I'll have 2x. So minus 3x is coming here as plus 3x. And then this 2 is going here as minus 2. So I have 12 minus 2 because it's positive here. When it crosses over, it becomes a negative. 2x plus 3x is 5x. and this is equal to 10 because 12 minus 2 is 10. Now I have 5 times x. To let x stand alone, I'll have to divide both sides by 5. Now this 5 will cancel out. 5 here crosses out 1, 5 here 2, and then my x is equal to 2. So finally, for number 4, x is equal to 2. And then for number 5, we have 2x plus 3 equals 6 minus 2x minus 3. So first of all, there's a bracket here, so I want to remove the bracket. So I'm going to repeat what is here. 2x plus 3 equals 6 minus. Now, once you see minus, there's usually a 1 here we don't write, okay? So I'm saying it's going to be like minus 1 multiplying positive 2x. And that's going to give me minus 2x. Now, minus 1 times minus 3, or simply minus times minus 3, is going to give me a positive 3. So now that I've been able to remove the bracket, the next thing is to group the common terms. So the 2x and this minus 2x must come together. I'll move this minus 2x to join 2x here to get 2x plus 2x. It is minus 2x. So when it crosses the equal sign, it becomes positive 2x. And this is equal to 6 plus 3. Now, this plus 3 also has to move to join the 6 plus 3, okay? The 2, this minus 2 was already gone. So I'm left with 6 plus 3. I've written it down. I want to move this plus 3 also to join. So it becomes minus 3. Now 2x plus 2x is 4x. And then this 3 is canceling out this 3. So I have left 6. To make x stand alone, I must divide here by 4 and do the same here. 4 cancels out 4. I have the x equals 1. And this is going to be 2 cancels through 6 3 times over 2. So x is equal to 1.5. So finally, we have for number 5, x is equal to 1.5. So these are the results of finding the value of x for each of these polynomials or each of these algebraic expressions. Okay. This is showing the process that I've gone through with all the examples that I have looked at. So just look at them carefully and then give them a try. Okay. This is again demonstrating what we have done in the previous pages. So you can take your time and look at them. Now here are some examples for you to give it a try. So take your time, pick your exercise book and your pen, and then try these 5 equations. Solve for x. That is, make x stand alone. So here are some key points to take note of when you are solving linear equations. This is a challenge expression for you. A number is doubled and then 5 is added to the result. If the final answer is 19, what is the number? Can you write down this expression? Okay. So now we are moving on to know equations that involve 2 variables. The first one we looked at was linear equations. That is, equations that involve 1 variable. Now we want to look at equations that involve 2 variables and attempt to solve for such equations. Once we are looking for equations that involves 2 variables, we cannot solve an equation, a single equation that has 2 variables. So we need 2 such equations so that we can solve for the 2 variables. Once we have 2 equations like this, we say that we have a system of equations. So we call it simultaneous equations because you have two linear equations in two variables and you are solving them at the same time. So a system of simultaneous linear equations consists of two or more equations with multiple variables, that is two or more variables. The goal is to find the values of the unknown variables that satisfy all the equations in the systems. So if you look at these two equations, the first one is 3x plus 4y equals 31. This is our equation 1. And then 2x plus 3y equals 22 is our equation 2. Let's continue. For these two systems of equations, x is equal to 5, y is equal to 4. Let's see if that is correct. For the first one, 3x plus 4y equals 31. If x is equal to 5, we have 3 times 5 plus 4 times 4 because y is equal to 4 equals 31. 3 times 5 is 15. 4 times 4 is 16 equals 31. Indeed, 15 plus 16 is 31, and that's also 31. So the fact that x is equal to 5 and y is equal to 4 satisfies equation 1. And then I assume it also satisfies equation 2. Therefore, the solution to this system of equation is that x equals to 5, y equals to 4. Now, I have just given you the solution. There is a way that you can solve for this x equals to 5, y equals to 4 when you are given such a system of equations. And that is what we want to look at this point of the lecture. There are two methods of solving systems of equations or simultaneous equations. The first method is using the substitution method, and the second method is using the elimination method. Let's look at both of them step by step. So for substitution, you solve one equation for one variable. Then you substitute the expression for the variable in the other equation. Simplify and solve for the remaining variable. And then you substitute the solution back into one of the original equations to find the other variable. So as an example, let's solve the system of equation x minus 2y equals 4, 3y plus x equals 19. So I'm going to write down the equation just to the up here so that you can reference it. Equation 1 is x minus 2y equals 4. Equation 2 is 3y plus x equals 19. This is equation 1. This is equation 2. So how do we solve? Let's solve the first equation for x. To solve the first equation for x, we have the first equation is x minus 2y equals to 4. So I have to move the negative 2y to the other side to join 4. And that gives us x equals 2y plus 4. So this is after solving the first equation for x. Now I'm going to put in x equals 2y plus 4 into the second equation. So I have 3y. Second equation is this, okay? You always reference it. 3y plus x. And x is from here, 2y plus 4. So I write it here, and it's equal to 19. Let's now simplify. If I remove the brackets, I'm going to get 3y plus 2y plus 4 equals 19. So 3y plus 2y is 5y plus 4 equals 19. I can let this 4 cross over to join the 19. And since it's positive 4, when you cross it becomes negative 4. So I'm going to have 5y equals 19 minus 4. Now 19 minus 4 will give you 15. That is how come I have here 5y equals 15. To further simplify to get y, I divide both sides by 5. And here by 5. 5 cancels out 5. 5 goes here, 1 goes here, 3. So I have y equals 3. So I have been able to solve for y, and I have y equals 3. Now I'm going to take y equals 3 and put it back in equation 1, okay? Equation 1 was simplified to this. I can also use this one. So I have x equals 2. I'm referencing this, please. X equals 2y, and y is 3. So I put it there, 2 times y plus 4, giving me 2 times 3 is 6 plus 4, and it's equal to 10. Therefore, we are saying that x is also equal to 10. So finally, I have the solution as x is equal to 10, y is equal to 3, which is the solution to this system of equation. X minus 2y equals 4, 3y plus x equals 19. Let's look at a method of elimination. These are the steps. Pick a variable to eliminate. Multiply one or both equations so that the coefficients of the chosen variables are the same. Add or subtract the equations to eliminate the variable. Solve for the remaining variable, and then substitute the solution into one of the original equations to find the other variable. Reading these steps is not the most important as knowing how to go through the steps. So let's go through an example and see how the process evolves. We want to solve these two systems of equations. We have 2x plus 3y equals 14 and 3x minus 5y equals 2. So what do we do? These are the equations. Two x plus 3y equals 14 is equation 1. Then I have 3x minus 5y equals 2 is equation 2. So let's look at the method of elimination. Multiply both equations to make the y coefficients the same. So I'm going to take equation 1. I'm going to multiply through the whole of equation 1 by 5. So when I multiply through the whole of equation 1 by 5, I have 5 times 2x plus 3y, and then 5 times 14. Always make sure that as I'm talking, you're looking at going back to reference the original equation so you do not get confused. Now 5 times 2x is 10x, 5 times 3y is 15y, and 5 times 14 is 70. So I've transformed equation 1 to look like this. So I'll say this equation 3. Now I'm going to multiply through the whole of equation 2 by 3. So I have 3 times 3x giving me 9x, 3 times minus 5y giving me minus 15y, and 3 times 2 giving me 6. So I've transformed the whole of equation 2 to look like this, and that's equation 4. How did I know whether to multiply equation 1 by 5 or 4 or whatever? I have to just study the original equations. I knew that I want to make the coefficients of y the same. It's not about the operatives. Forget about the operatives. I want to make just the numbers the same. How do I make 3y and 5y have the same coefficients? I thought that if I multiply 3 by 5, I'll get 15. And if I multiply this 5 also by 3, I'll get 15. Then I'll have 15y, 15y for both of them. Now, if I'm multiplying this 3 by 5, I must multiply the whole equation here by 5 so that everything will balance. And if I multiply this 5 by 3, I must multiply every other term in the equation also by 3. That is why you saw me do it that way, multiplying through the whole thing by 3 and the whole thing by 5. Now, the operations will take care of itself as we progress, so don't focus too much on them. I have two new sets of equations. I have 10x plus 15y equals 70, and 9x minus 15y equals 6. Now, the next step is to eliminate the one that has the same coefficient, which is y. Y has 15, the numerator, equation 3 has positive 15y, equation 4 has minus 15y. Once they have the same number as coefficients, I can eliminate the variable y. What do I do? 15y and minus 15y come together. How do they come together to be equal to 0? This is positive 15y. If I add it to minus 15y, I'll get 0. So if I say 15y, positive 15y plus minus 15y is going to be equal to 15y minus 15y, and that's equal to 0. So what I can do is to just add positive 15y to minus 15y. And that means I'm adding equation 3 to equation 4. Because once I'm adding these two terms, I must add the 10x and 9x and also add a 70 plus 6 so that everything will be balanced. Okay. So now what I'm saying is I'm going to add equation 3 to equation 4. That means that I'm going to say 10x plus, I like to keep it simple this way by multiplying, putting them head to head like this. Put them head to head like this and just sum them. So 10x plus 9x is 19x. Plus 15y plus minus 15y is 0. And then 70 plus 6 is 76. So I have 19x equals 76, which is what we have here, okay? 19x equals 76. So how I simplify this by dividing both sides by 19, and I have x equals 76 divided by 19, and x finally is equal to 4. So here I have x being equal to 4. What I do next is take one of the original equations and then I put in x equals to 4. So I'm going to take equation 1. Equation 1 is up here. 2 times x, which is 4, plus 3y equals 14. 2 times 4 is 8, plus 3y equals 14. I want y to stand alone, so I can move this 8 to join 14, and it becomes 14 minus 8. Then I have 3y equals 14 minus 8 is 6. I divide both sides by 3, and then I get y is equal to 2. So finally, the solution to this system of equations by the method of elimination is x equals to 4 and y equals to 2. Okay, so here's another example. Solve the following systems of equations. The first one, you're asked to use substitution, and then the second one, you're asked to use elimination. So let's start with the first one. Using the method of substitution, I have 7x plus 2y equals 47, and then 5x minus 4y equals 1. I'll label this as equation 1 and this as equation 2. So I'm going to take equation 1 I'm going to take equation 1 and then make x the subject. This is what I'm working on now. I'll make x the subject. So I'm going to have 7x plus 2y equals 47. To make x the subject, 7x will stand alone, and then I move the 2y over to the other side. So I get 47 minus 2y. I divide both sides by 7 and divide here 2 by 7 to get x is equal to 47 minus 2y all over 7. So now I can take this x value and put it in equation 2. So we come to equation 2 here. I have 5x, but x is equal to 47 minus 2y over 7. So 5x minus 4y equals 1. There's 7 in the denominator, so I have to multiply through every term by 7, okay, to get rid of this 7. So I'll multiply here 5 times 7 times 47 minus 2y over 7 minus 4y times 7 equals to 1 times 7. Remember I said I'm multiplying through everything by 7. Now this 7 will cancel out this 7 to remove the denominator. So I'm going to have 5 times 47 minus 2y minus 4y times 7 is 28y. Yes, and then equals 7. 1 times 7 is 7. So I'm going to draw a line and continue here. Okay. So now simplify. I'm going to multiply, open the bracket. So I multiply 5 throughout everything. 5 times 47 is 235. So I have here 235 minus 5 times minus 2y is minus 10y minus 28y equals 7. Minus 10 minus 28y simplifies to minus 38y. And then minus 235 will go and join the 7 to become 7 minus 235. 7 minus 235 is minus 228. So I have here minus 38y equals minus 228. So I divide both sides by minus 38 to let y stand alone. Divide here by minus 38 and then divide here by minus 38. I have here y. The minus 38 crosses out minus 38 and I have left y equals. Now minus 228 divided by minus 38 gives me 6. So I have y is equal to 6. Now I'll take y is equal to 6 and put it in the second equation. So I'm going to get 5. No, I can put it in the first equation because I solved all of this using the second equation. You can put in any of the equations anyway. I want to put it in the first equation. Yeah. Because I got y equal to 6 from the second equation. So it's safer to put it in the first equation. So I have y equals to 6. Putting it in the first equation, I have 7x plus 2y, which is 6, equals 47. So then I have 7x plus 2 times 6 is 12, equals 47. Then I have 7x. The 12 moves to the other side to become negative. So it's equal to 47 minus 12. And that's giving me 35. So I have 7x being equal to 35. And then I divide both sides by 7 to get x being equal to 5. So finally, I'll say that the solution to this system of equation is that x is equal to 5 and then y is equal to 6. We can check. Let's take the first equation, for example. Okay, 7 times x, which is 5, is 35. And then 2 times y, which is 6, is 12. And 35 plus 12 is 47. So we know that this solution we have is correct because I just verified. You can verify with any of the two equations. Take one of the equations, fix in the value of x, fix in the value of y, put this in your calculator and see if you get the value on the other side of the equation. So this is the solution with the substitution method. Let's look at the method with the elimination. So I'm solving a method. I'm on number 2 now, the elimination method. So I have here 3x plus 7y equals 27, and then 5x plus 2y equals 16. This is equation 1. This is equation 2. So to do elimination, I would choose one variable. That's the first thing. Then I'll try to eliminate that variable. And I do that by making sure that the coefficients of that variable are the same in both of the equations. So I'll choose x. Okay. So I'll say that I choose x. I want to eliminate x. Now for the first one, x has a coefficient of 3. And for the second one, x has a coefficient of 5. So how do I make them the same? If I multiply 3 by 5, I get 15. If I multiply 5 by 3, I get 15. So then I can make them to have a coefficient of 15, 15. So let me do that. But once I'm multiplying this one by a particular number, I must multiply through all the terms also by that same number. So I'll say that I'm going to multiply through equation 1 by 5. The whole of equation 1. Okay. So 5 times everything in equation 1, 3x plus 7y equals 27. Now 5 times 3x is 15x. 5 times 7y is 35y. 5 times 27 is 135. So this is my new equation 3. It's replacing equation 1. I also want to multiply through the whole of equation 2 by 3. So 3 times 5x plus 2y equals 16. Now 3 times 5x is 15x. 3 times 2y is 6y. And then 16 times 3 is 48. This is my new equation 4, replacing equation 2. So I have now equation 3, equation 4. Each of the x's, the x variables have the same coefficients, 15, 15. How do I get rid of it? I can subtract this 15x from this 15x. That will look like taking out equation 4 from equation 3. Okay. So here I'll say equation 3 minus equation 4. Now, if I put them head to head, let me put them head to head. 15x plus 35y equals 135. And then here I have 15x plus 6y equals 48. So 15x minus 15x, I'm subtracting. No, 15x minus 15x is 0. 35y minus 6y. Remember, it's 3 minus 4. 35y minus 6y is 29y equals, and then 135 minus 46 is 89. I can divide both sides by 29 to make y the subject. So I have here y equals 89 oh, divided by 29 is giving me, it's still the same. Nothing is changing. I hope I'm not making a mistake. Please, if you are going through, check. Just in case I've made a mistake, then you correct it. Okay. So I have here y is equal to 89 over 29. This I'm getting fractions as well. Okay. Let me put y into equation, any of the original equations. Okay, any of them. And then find the value of x. So I'm going to put y into equation 2. All right, equation 2. Any of the original equations. So I have 5x plus 2y. Y is 89 over 29 equals 16. So my focus now is to make x the subject. So I have 5x is equal to 16 minus 2 times 89 over 29. I moved this whole term, 2 times 89 over 29, to the other side of the equation. Let me simplify this. So 16 minus 2 times 89 over 29 gives me, so we'll say 5x is equal to 286 over 29. I must divide both sides by 5, and then here to divide it by 5. So I'll have x being equal to 286 over 29. Divided by 5 is the same as times 1 over 5, and that's equal to 286 divided by 286 divided by 29 times 5, which is, these values are quite huge, which is 286 divided by 145. These x values are quite strange, but we'll see. So we have x being equal to 286 over 145, and then y being equal to 89 over 29. Let me fix them back into the original, any of the original equations, and let me see if I'm going to get the correct one. So 3 times x is 286 over 145. So I choose the first equation, 3x plus 7y equals 27. So 3 times x is 286 over 145 plus 7y. Y is 89 over 29 equals to 27. Okay, let me see if this is correct. This is plus 7 times 89 over 29. It's wrong. It's giving me 27.4. So there's an error in my solution. I'm not going to go through it again. When you are going through this course, you can figure out whether I made the error and correct it for me, and you can prompt me in class that there's an error, because this left-hand side, when I calculate, I'm getting 27.4. I should get 27. 27.4 is not the same as 27, so there's an error in my solution. But the process I went through is right. So please kindly do well to um, help me find where the problem is when you are going through it, and then you can prompt me on it. All right. So let's proceed. So for question 2, I wasn't able to give you the correct answers for x and y, but when you are trying it, make sure you please put in there. Let's see if you were able to come up with the right answers. Okay. You could also use the graph system where you plot the two equations on the graph sheet, and where those two lines intersect, you find the x value corresponding to that intersection and the y value corresponding to that intersection, and then that becomes your solution for x and y. But we will not be doing that in this course. So these are some practice problems for you. You can solve each of these systems of equations. These are very simple systems of equations that you can practice with. Now let's look at word problems. Word problems can be quite tricky. They require practice to translate English sentences into mathematical equations. The key idea is identify your key phrases and operations to set up the problem correctly. So you can see common phrases like a number, which will become a variable x, or it can be a variable y, variable z, variable a, any variable at all, any letter. If you see is, it mostly represents equal to. If you see more than, represents addition, often written in the reverse order. So for example, 3 more than a number. A number, we'll use x to represent. So x, 3 more plus 3. Okay, so we didn't say 3 plus x. It's the reverse, 3 more than a number. So mostly you write that unknown number first, then you add on the remaining things. So 3 more than a number. So I write the x and then add 3. We also have less than. It represents subtraction. It's also written in the reverse order. So you say 4 less than a number. So you write the number and then you subtract 4. What are the steps? Identify your unknown variable. Translate your key phrases into math operations. Then you set up your equation and you solve your equation. Then you interpret the solution in the context of the problem. Always double check your solution by substituting it back into the problem. You realize that in the previous example I solved with the simultaneous equation, the last example I solved, I was able to verify whether my x and y is correct by putting it back into the equation. And I noticed that my x and y, there was a problem with the solution. It wasn't right. So you must always make sure that whatever answer you get, you put it back into the equation to verify. Okay. So let's try some examples here. So you set up the equation and then you solve. The problem is 28 less than 5 times a number is 232. What is the number? So I have here, I'm always going to write my number first. Okay, that unknown number first, the variable. So it says 28 less than 5 times a number. So first of all, I write the number I don't know. And they said it's 5 times that number. And it is 28 less of it. So minus 28. 28 less than 5 times a number is, it stands for equal to 232. Okay. 28 less than 5 times a number. As I said, you always write the unknown number first, the variable. 5 times the variable less 28 is equal to 232. And that's what we have here. And then you move on to solve for x like we did for the case of linear equations, solving for x. So after going to the solution, you should have x being equal to 52. Here's another example. 15 more than 3 times a number is the same as 10 less than 6 times the number. 15 more than 3 times a number is the same as 10 less than 6 times the number. So let's attempt to write this down. First of all, S here means that there's an equal sign and there are two sides of the equal sign, okay? So 15 more than 3 times a number. So we have the number, 3 times the number, 15 more than 8, so plus 15, is the same as 10 less than 6 times the same number, also the same x. You don't change the variable. Less than 10 less 6 times the number. So this is how you set up the equation. You know that we always said is the reverse. So 15 more than means the number plus 15. And the number is 3 times the number. So 3x plus 15 is the same as. So it's equal to 10 less than. It will be the reverse. So 10 will come after. So 10 less than 6 times the number. So there's 6 times the number, which is 6x minus 10. Remember, it says the number. So you must make sure you use the same variable. The first one says 15 more than 3 times a number. And I chose x. And it says it's the same as 10 less than the number. So you're referring to the same number. So you must use the same variable. And we have 3x plus 15 equals 6x minus 10. At this point, you use the process we went through to solving linear equations to solve for x. And when you're able to simplify, you should get x equals 25 over 3, which is approximately 8.33. Yeah. Let me verify this answer is correct. This is how you verify. You take 3. We said x is what? 25 over 3 plus 15, okay, equals 6. X is 25 over 3 minus 10. Now, the 3 is canceling the 3. We have 25 plus 15 equals 3 here cancels out 6 remain 2. 2 times 25 is 50. So 50 minus 10. 25 plus 15 is 40. 50 minus 10 is 40. So yes, x equals 25 over 3 because it satisfies both sides of the equation gives you 40, 40. And that's how you test to see whether the value you have gotten is correct. Okay. Here is another example. This is about consecutive integers. Right. The problem says the sum of 3 consecutive integers is 93. What are the integers? You must first of all understand the various words in the question. What are integers? Integers are numbers that are, it can be positive or negative integers, okay? But we know that they follow after each other. They are numbers that are whole numbers in the sense of, so like 1, 2, 3, 4, 5, or -5, -4, -3. We have negative integers. When we say consecutive integers, it means that the integers follow after each other. There's no gap in between them. So consecutive integers can be like, if I start from, if the first number is 5, then we have 5, 6, 7, 8, 9. They are consecutive. They follow each other like that. If the first number is, let's say, 10, then the next consecutive number is 11. The next consecutive is 12. The next consecutive is 13. So these are consecutive integers. Now the question is saying that the sum of 3 consecutive integers is 93. We don't know to know the consecutive integers, you must know the first integer, but we don't know. So let's use x as our first integer. Then what will be our next integer? Remember, I gave you an example of, let's say, 5, 6, 7, 8 as consecutive integers. So if x is, for example, equal to 5, how do you get 6? You simply add 1 to x. So the next integer will be 5 plus 1, which give you 6. So it will be x plus 1. Okay. Now to get 7 is 5 plus 2. 5 plus 2 gives you 7. So the next integer is x plus 2. Okay. So these are 3 consecutive integers. Why you know the first, let's say the first one is 7. Second one will be what? 7 plus 1, which is 8. Third one, 7 plus 2, which is 9. And this is correct. 7, 8, 9. They follow each other like that. So they qualify as consecutive integers. But I don't know the first number yet. So I'm going to use x as my first consecutive integer, x plus 1 as number 2, x plus 3 as number 3. So I list this as my consecutive integers. Now the question says the sum of these 3 is 93. So to add, I say x plus 1 plus x plus 2 should be equal to 93. Then at this point, I can simplify. X plus x is what? 3x. And then 1 plus 1 plus 2 is 3 equals 93. So I can move this 3 to the other side. Then I have here, it's continuing from here, okay? 3x plus 3 equals 93. I move the 3 over to become 93 minus 3, and then I have 90. 3x. Divide both sides by 3, we have x equals 30. So let's check. If x equals 30, then it means the first consecutive integer is 30. Then the second is 31, the third is 32. If you add 30 plus 31 plus 32, you get 93. So our solution is correct. But take note, the question asked you for what are the integers. So when you get x equals 30, don't stop there. You need to know the 3 integers. You are being asked for the integers, not just for the first integer. So you use this x plus 1, x plus 2 to find all the 3 integers. So if x is 30, then second one will be x plus 1, which is 31. Third one will be x plus 2, which is 32. All right. Here's another example. Find 3 consecutive odd integers such that the sum of twice the first, the second, and 3 times the third is 152. So the first thing is to know is to just, you always must know your first integer and you use a variable to represent it. So I'll say that my first integer is what? X. Because I don't know. Once you don't know, you always have to use, like the previous examples, a number. You use X or a variable for it. So I'm using X for my first consecutive odd integer. But first of all, let's look at how consecutive odd integers look like. Examples of consecutive odd integers. If my first odd integer is, let's say, 3, the next consecutive odd integer will be 5. It has to be the next odd number. And then the next odd number is what? 7. The first odd number I chose was 3. Then the next odd number has to be 5. The next odd number will have to be 7 because they follow up like that. And these are odd numbers. It cannot be 4 because 4 is an even number. And our focus here is consecutive odd integers. So if, let's say, I say that, I don't know, 357 is just an example. So if I choose X as my first consecutive integer, which I don't know, how did I get, if X, for example, X is equal to 3, how do I get 5? I simply add 2 to X to get 5. How do I get 7? I simply add 4 to X to get 7. So my first consecutive integer, odd integer is X. The second odd integer is X plus 2. And the third consecutive odd integer is X plus 4. So I have my 3 consecutive odd integers. This one I just use as an example too, because I don't yet know the numbers. I use them to get this, okay? The question says that you have 3 consecutive odd integers and they're like this. The sum of twice the first, this is the first, so twice the first is 2x. And the second is x plus 2. And 3 times the third, this is the third, so 3 times x plus 4 should be equal to 152. So it's good to always label. You can say this is first, second, third, okay? All right. So the sum of twice the first, the second, and 3 times the third is equal to 152. At this point, you open brackets and then you simplify to get the value of x, and this given us is equal to 23. So you can practice this and see if you also had 23. So here are some practice problems you can try your hands on. More practice problems you can try your hands on. So this is a summary. Word problems require careful interpretation of phrases, okay? And you need to always practice so that you can improve your problem solving skills. The final thing we are looking at for today is quadratic equations, an introduction to quadratic equations. A quadratic equation contains a term that involves x squared. So for quadratic equations, they also like polynomials, but then the degree of that polynomial is 2. Okay, so once you see that a term has a degree of 2, we consider that as a quadratic equation. So it has this form: ax squared plus bx plus c equals to 0. A and B are coefficients, C and 0 are constants, and then the x's are variables. Note that A cannot be equal to 0 because the fact that there has to be a term there that has a square of 2 or has an exponent of 2 to make it a quadratic equation is important. As for B, can be equal to 0, C can be equal to 0, but A cannot be equal to 0 because there has to be a term whose variable has an exponent of 2. Okay. So example, 3x squared minus 5x plus 2 is equal to 0 is an example of a quadratic equation because there is a term whose variable has an exponent of 2. Again, x squared plus 7 is equal to 0. It's a quadratic equation because there is a term whose exponent is equal to 2. Okay. So this one, you see, you don't have an x term in there, but it's okay. Once we have a term whose variable has an exponent of 2, it qualifies as a quadratic equation. So how do we solve quadratic equations? You can use the method of factorization, or you can use the almighty formula or the quadratic formula. Okay. Let's try using the method of factorization. As an example here, solve 3x squared equals 27. So what I can do is I'll make it look like a quadratic equation by bringing this 27 to the left-hand side so that I can have 0 on one side of the equation. So then if I bring 27 here, it becomes minus 27. So I have 3x squared minus 27 equals 0. Now I have to factor out because I'm using factorization. So in factorization, look at both terms and look at if you can find a common term amongst them. Now, if I look at 3, I feel like 3 can divide 3 and can also divide 27. So I can factor out 3. Okay. All right. So here I can say I have here 3x squared minus 27 equals 0. I think 3 is common amongst these two terms. So I'll bring out 3, and then what I'll be left with for the first term is x squared, because 3 times x squared is 3x squared, so nothing changes. Then minus what times 3 gives you 27? 9. 3 times 9 will give me 27. So when I bring out 3, I have 9 left here, and that's equal to 0. So now I have two terms. I have 3 is equal to 0, or x squared minus 9 is equal to 0. Because for 3 times x squared minus 9 to be equal to 0, either 3 is 0 or x squared minus 9 is 0. We all know that 3 is not 0, so this is out. So I can solve for this to get x. All right, so first of all, this x squared minus 9, I can open it up to get x minus 3 and then x plus 3 being equal to 0. There's a particular property in math that allows you to do this. I don't remember the exact term, but if you simplify this back, you get back x squared minus 9. Okay. So in this case, x minus 3 times x plus 3 is equal to 0. If that's the case, then we are saying that either x minus 3 is equal to 0 or x plus 3 is equal to 0. And this implies x is equal to 3, and this implies x is equal to minus 3. So the value of x is equal to minus 3 and minus 3 or 3. So we have the solution x equals 3 or x equals minus 3. Okay. This property, you can go and look for it. X squared minus 9, giving us x minus 3, x plus 3. The x squared minus 9 here. X squared minus 9 is the same as x squared minus 3 squared. You know, 3 squared is the same as 9. So if you have a squared minus b squared, you can open it up and make it a minus b, a plus b. That's the property I used for this side, okay? You can go and read more on this property. So practice solving the following quadratic equations using the method of factorization. I will try the first one, then you continue with the rest. So the first one we have 5x squared plus 3x equals 0. Already it's looking like a quadratic equation because we have 0 on one side of the equation and there is a term with a variable whose exponent is 2. Now among 5x squared and 3x, they have a common term, which is x. There's x here, there's x here. So I can factor out x, okay? So I bring out x. I have left here 5x, and I have left here 3 equals 0. Because indeed, if I multiply this x back into this bracket, I'll get back 5x squared, and I'll get back 3x. So what does this mean? For x times 5x plus 3 to be equal to 0, then it's either x is equal to 0 or 5x plus 3 is equal to 0. Then let me solve for 5x plus 3 equals to 0 to see what x is. Here I have 5x equals minus 3, and then x equals minus 3 over 5. So for this particular quadratic equation, x is equal to 0 or minus 3 over 5. Okay. So go through the similar processes to solve for this quadratic equation using the method of factorization. I'll solve number 2. I didn't want to solve anymore, but let me solve number 2 also to give you an idea of another method. I mean, different styles of to solving it. X squared minus 5x plus 6 equals 0. I'm now on number 2. All right. So I have here, with this particular one, what I want to do is I'll open up this minus 5x. So I have x squared. I'm going to make minus 5. I'll break it up. So I'm going to make it minus 2x minus 3x plus 6 equals 0. Nothing has changed. This minus 2x minus 3x is the same as minus 5x. Minus 2x minus 3x is equal to 5 minus 5x, okay? So I just opened up this minus 5x to look like minus 2x minus 3x. So I can take this first to x squared minus 2x. There's a common term there. There's x in both sides. So I bring out the x and I have left x minus 2. Now when I take minus 3x and 6, 3 is common among them. So I'll bring out minus 3. Then I have left x minus 2 because this minus 3 times minus 2 is equal to 6. Okay. And that's equal to 0. If you simplify this, you should get back x squared minus 5x plus 6. So now x minus 2 is what is in the bracket. So we consider it as 1. So we have x minus 2 being equal to 0. And then also this x minus this 3, we consider it as 1. So we can find x here. This implies that x is equal to 2, and this implies that x is equal to 3. Therefore, for this number 2, the solution to the quadratic equation is that x is equal to 2 or 3. So now try your hands on question 3, 4, and then 5. All right. There is also the method of using the quadratic formula. And this is the quadratic formula. It's a very simple thing. Once you have the formula, the most important thing is knowing what A is, what B is, and what C is. And from our quadratic expression, we have ax squared plus bx plus c. So, and this is the formula. So let's see something here. The question here says solve x squared minus 3x minus 2 equals 0. Now we know the quadratic formula to be ax squared plus bx plus C equals 0. So if you compare this one to this question, then A is what? 1. There's a 1 here we are not writing. Okay. So A is equal to 1. What is B? B is equal to minus 3. Okay. Minus 3. And then C is equal to minus 2. If A is equal to 1, B is equal to minus 3, and C is equal to minus 2, we are almost done. It's just about taking the quadratic formula and fixing in the value. Now the formula is what? X equals minus B plus or minus square root of B squared minus 4AC all over 2A. What you can do is to separate them. Because of the plus and minus here, just separate them. You have the first one is going to be X equals minus B plus square root of B squared minus 4AC all over 2A. And then this is your x1, the first one. Then your x2 is going to be minus B minus square root of B squared minus 4AC all over 2A. So for the first x1, I use plus. For x2, I use minus. Because the question says plus or minus. So you fix in the values of B, A, and C into it, and then you simplify using your calculator. You do the same thing here. Please make sure that if it's minus 3 and you're putting it into B, you put it in well so that the negatives are not affected in a bad way. Okay, right. So this is how you go about solving for quadratic equations using the almighty formula or the quadratic formula. And that is what we did here. So here we fixed in A equals 1, B equals minus 3, and C equals minus 2. Okay, so for the first one, X equals, the formula is minus B, and B itself is minus 3. So how it's the formula is minus B, so it's minus B, and B is minus 3. So we have minus into brackets minus 3. The minus 3 here is B. The minus here is from the formula. Plus or minus root of B squared. B is minus 3. You have to put the B, once it's negative, put it in bracket first before you raise it to the 2, because minus 3 all squared will give you a positive number. If you don't put it in bracket, you end up getting negative 9, and that will be wrong. Minus 3 times minus 3 is 9. So you put your B, once it's negative, put it in bracket and square it. Then minus 4, according to the formula, 4 times A is 1, times C is minus 2. I've put it in a bracket. All over 2 times A is 1. So at this point, you can separate the two. The first one, use positive here. Second one, use negative, and then simplify with your calculator to get X equals 3.5616 or X equals 0.5616. All right. So you can attempt with a quadratic formula to solve the following systems of equations. The following quadratic equation, check through your handout. If you check through your handouts, you can always refrain. The formula is in there, so you can look into it and then go through the solution. So here are more examples. Solve the following quadratic equations. First of all, with this one, you can use factorization. And then with this method, you can use the quadratic formula. This is the quadratic formula. Okay. Thank you for being a part of this lecture.